When it comes to making hitboxes in Roblox Studio, there is one method that I prefer over the rest: magnitude checks. To fully understand what's going on, let me explain exactly what magnitude is. Magnitude refers to the second property of an object called a vector, with the other property being a direction. We can picture a vector as a directed line segment whose length is the magnitude of the vector with an arrow indicating the direction. Now, when it comes to doing a magnitude check, we first need to get what's called the resultant vector, which is just a sum or difference between two vectors. This resultant vector is going to be the most useful part of doing the magnitude check since it gives us almost everything we need. And to get it, we first have to get the two positions of our players. We then have to determine who's attacking who so we can subtract our vectors in the proper order. You always want to subtract the enemy's position from the attacker's position. This will result in a vector that points in the direction of the enemy relative to where the attacker is. This new resultant vector gives us two very key components in solving our problem. We can get the distance between the two players using the dot magnitude property of the vector object, and we can also get the direction of the vector by using the dot unit property. All we have to do now is determine the range of our attack. Let's say in this example it's 5, and our resultant vector came out to be 7. Simply check if the magnitude is less than or equal to our range, and if it is, then we consider it a hit. And that's pretty much all you need to know about what magnitude hitboxes are and how they work. However, there is one last thing I did not mention about doing a magnitude check, and that is that on its own, it has no way of knowing which direction is forward. And what I mean by this is that you could be facing forward and attacking, and the enemy could be behind you, and they'd still get hit. And that's because doing a magnitude check is an overall range about where you start. This is by far the biggest downside to doing magnitude checks, if you don't know what you're doing. See, there is one more thing you can add to this check, which gives you the ability to limit the angle at which you're allowed to register a hit at. This check is what's called a dot product check. The dot product of two vectors can be thought of how similar or aligned the two are. The results of this being is that if they are perfectly aligned or have the same slope, the dot product will output a value of 1. If they are facing perpendicular, the dot product will output a value of 0, and if they are facing completely opposite directions, it will output a value of -1. And don't worry about doing this in the correct order. The dot product is actually commutative, meaning the order doesn't matter. Now, in this case, our second vector that we will be using is actually our character's look vector. Before we actually do our dot product calculation though, make sure that both the vectors are normalized, basically meaning that their magnitudes are equal to 1. You can do this by calling dot unit on your vector object. Now, you can leave the dot product number as is, or you can do what I like to do, which in my opinion helps with readability, and that is to convert this number into an angle in degrees. You can achieve this by running your dot product through an arc cosine or acos function, which gives you the exact angle in radians. We can then take this value and run it through a radian to degree function, or in my case, math.degree, and this will output the exact angle between the two vectors. Combining everything we now know, we can construct our two checks to register a hit: a range check and an alignment check. And after all is said and done, we should end up with a result that looks like this. If you enjoy this style of content, or found this helpful in any way, be sure to like the video, and maybe even consider subscribing. I'll see you in the next one.